In this video, we are going to discuss a topic of BSc's second year, third semester, that is stable and unstable equilibrium. So, let's start. We know when a body moves on a smooth curve as shown in this figure, then it will take different positions. So, here the body is at rest at positions A, B, and C. They are also the positions of maxima and minima of the curve. Position A and C are the positions of body where the body is in stable equilibrium, and position B is the position where the body is in unstable equilibrium. As per the definition, if the body is slightly displaced from the position of rest, that is position A and C, then it will try to come back to its original position of rest. Here the equilibrium of body is stable, so we can say the body is in stable equilibrium. Whereas if it is displaced from the position at B, then it will try to go further away from the original position. Here we can say that the equilibrium of the body is unstable. Now let's go further and discuss the stability and instability of body with its center of gravity, and we have marked center of gravity as CG in the figure. So here we have three cases to discuss, that are stable equilibrium, unstable equilibrium, and neutral equilibrium. In these cases we will discuss the case of sphere whose center of gravity is not at the geometric center of the sphere. So we have three cases. We will discuss them one by one. Let's start with case 1, that is stable equilibrium. As you can see in this figure, if the center of gravity lies on the vertical line through the point of contact and it is below the geometrical center that we have marked as C, geometrical center of sphere, and the sphere is slightly displaced, then it tends to come back to its original position of rest. This is the position of stable equilibrium. Also, for stable equilibrium, potential energy is minimum and the height of center of gravity from the point of contact is minimum. Here, if we take Z as the height of center of gravity of body from the point of contact, as you can see in this figure, this is center of gravity and this is point of contact, and we have taken this height as Z and represented as the function of theta, which represents the position of body. Then at rest, the derivative dz by d theta is equal to 0. On solving it, it gives different positions of equilibrium, that are theta equals alpha, beta, gamma, and so on. The equilibrium is stable at theta equals alpha when d2z by d theta square is greater than 0. This is the condition for stable equilibrium of a body. Now let's come to the second case, that is unstable equilibrium. So here we can see in this figure, if the center of gravity lies on the vertical line through the point of contact and it is above the geometric center of the sphere, as we can see here, and the sphere is slightly displaced, then it tends to go away from its original position. Okay, so this position is known as unstable equilibrium. For unstable equilibrium, we have potential energy maximum and height of center of gravity from the point of contact is maximum. And at theta equals alpha, the double derivative of z with respect to theta is less than 0. This is the condition for unstable equilibrium. Now let's come to case 3, that is neutral equilibrium. So here in this diagram we can see if the center of gravity lies on the vertical line through the point of contact and coincides with the geometrical center of the sphere and is slightly displaced, then it will remain in equilibrium. In this case, we can say the body is in neutral equilibrium. Since the height of center of gravity does not change here, okay, it remains in its original position. d2z by d theta square equals to 0. So in this video we have discussed stable and unstable equilibrium, okay, and stability and instability of body with respect to center of gravity, and discuss the 3 cases. So that's all for this video. Thank you.